You're up.
That was really cool.
Take questions if we have any.
So the new STEM building, it's a LEED accredited building, and I'm just kind of curious what kind of design incorporations were made, because it's, LEED certified.
You're like,
Evan, if you notice, Evan's the one with all the letters after his name.
Yeah. Well, the biggest challenge for LEED on this project was the energy, which I went into a little bit. Running the energy model, we were quite a bit lower than what we had expected. Even with some of the thermal analysis that we showed with the details and just standard practices for our firm is to kind of, and even Vermont, the code is more strict here, energy-wise. So it's more in line with kind of LEED's expectations for energy. So using the advanced heat recovery system was the biggest piece to the LEED puzzle. A lot of other elements like using concrete for paving instead of asphalt for heat island reduction because it has higher reflectance. A lot of it, we're using a lot of recycled materials. We're using 100% FSC wood, and a lot of that's on the contractor to manage, which they are tracking very well for that. So recycled content, regional materials, indoor air quality is a mechanical. It's related to the mechanical systems as well. So we have all high quality filters and containment of contaminants. So all the custodial closets are isolated and have exhausts. Carpets, low VOC materials, adhesives, paints, ceiling systems. Trying to think. I mean, for us, the energy was the biggest challenge. And I would say, as far as technology goes, the most advanced use of technology in the building that contributes to LEED is the convective system and the heat recovery.
When you start to build STEM like in Revit, what's like the first kind of steps? Because I feel like you can't really start putting in MEP systems before anything else is in place. So like, how do you start like from scratch?
Right. On this project, the design started in SketchUp, just because the site has a lot of buildings in it and is a very complex site. So we quickly just grabbed some site information off Google Earth, brought it in through SketchUp, did some of our own site surveying, and then kind of improved the kind of visual aspects of the model, and then just quickly did some studies. This particular project was a design competition, so we submitted an architecture design to the university, and then once that was approved, we kind of had to stick to somewhat to that design, and then worked with the owner spatially. The parameters for how large the building is and the cost were there, so we had those to work with. After that, we go to the structural engineer typically and start working through kind of in general what needs to be used to construct the building. So once we have that shell kind of settled and then we bring it into Revit and start building those real elements. Because one of the challenges with Revit is that once you get going down a road, sometimes it can be, if you're using actual wall elements and you've got a certain size of the building, and you change the wall type or something, it can change the size of the building. It can get kind of, because of all that information, you can impact a lot. So you try to keep it simple and use kind of dumber walls, let's say, that don't have all that information at first, and kind of tweak it, and then once you've settled, then we set the actual depth of the wall, and then we would start giving information to our structural engineers. Because engineers like to have they don't want concepts, they like to have real information to work off from and run their numbers. And then with the MEP, it was driven mostly by the needs of the labs. I mean,
Right.
these labs, like Dave showed, are very intensive. I mean, there's gases going to them, there's a lot of exhaust, there's, you know, and then you need the heat to recover from their exhaust. So the energy model stuff that I showed where they're analyzing how much glass we have, and they use that to size the system. And then they used all of the kind of lab requirements to then size the exhaust for the system and kind of took it from there.
Did that answer your question?
Yeah. When the engineers are designing the structural component of the model, I guess what program do they use, like beyond hand calculation?
So can you repeat the question first? Because they couldn't hear, they probably couldn't hear.
Oh, yeah, so the question was, what program do the structural engineers use? So on this project, they did use Revit. They don't use Revit to run their calculations. So they use Revit for the 3D information, and it does have, they can export and import from Revit to their program. I don't know exactly what they use, but they use a secondary program. They don't do it in Revit.
What's the most extreme function you would do with Revit in terms of like sizing, load calculations, or like airflows? Because we're on the Revit class, and I remember they said something like you can design your air system, but it's more like a dummy version of what you're going to do because it's got to go through the engineering phase. So how much can you count on Revit for in terms of real calculation?
Right, I'll maybe pass this off, but I know for our consultants in design, again, they would use Revit as a import or export into Revit, and we would use it mostly for clash detection, design, sizing things, making sure systems worked on the design side. But for calculations, they would have a secondary program that they're using.
Yeah, I in my previous life as an engineer, now I'm in the construction world, I've used AutoCAD extensively. I haven't personally used Revit, but we would use the AutoCAD program to help size the distribution of the ductwork, so we knew what the total capacity of the system was. And then as you start working beyond the air handler, you have sizes for your ductwork or your piping. You know what your system capacity requirement is, 10,000 GPM or 10,000 CFM. As you build out beyond the air handler, you're sizing your ductwork smaller and smaller and smaller. You have to maintain certain flow requirements or pressure requirements in the system. And you can actually build all of those elements and information into your model that you can later on dump out to a report. Realize that at this point in time, a lot of engineers don't have the computer horsepower to generate those kinds of reports. So a lot of engineers, at least in the Northeast, I'm going to say, they still do it, a lot of it by hand. They'll use the model as a guide or an aid, but they're still doing the main calculations by hand. Anybody else?
What's a minimum size project before you go into some of this modeling? And I know there are different degrees of modeling, but
For us,
So what's the minimum size of a project, John's asking?
yeah, it gets probably deeper than that. For us, on our water treatment work, it has a little to do with the specs, but yet we haven't seen much. Water treatment's an old school business, and I haven't seen, I don't know, Megan, I don't think of one that's required BIM. So it's on us to decide when we want to use it. And the biggest factor for us is whether or not we're self-performing water. So if we're pouring our own concrete and doing our own process piping, probably any size we would model. So, or if we're doing our own field engineering, our own layout, we'd model it, at least to some extent. I don't know, a dollar amount, if it got under maybe 10 or 20 million, we might consider not doing it, but it's really becoming the way we want to do business. On the buildings and facilities side, it's either spec driven, the specs require, like this job require that we use BIM, or if we felt that the mechanical systems were so complex that we'd want to go through this process in 3D in advance, or build it first virtually, then we'd do it. So we've done this on the Vermont Health Lab, the Adventure Center up at Stowe, the Waterbury office project, anything that was somewhat complex.
Have you seen this type of software being used for other types of like heavy civil projects like bridges or tunnels, where they might be a little bit more simplistic as far as the systems that are going in?
Yeah, I mean, I think so. Yeah, I don't know what the tunnel, the tunnel, not the part we did, but the tunnel that was drilled, I'm not sure how much BIM they did on that.
Didn't we try to laser scan the inside, but it didn't work?
No, we laser scanned another small tunnel on that
okay.
job. But heavy civil, absolutely, they're doing machine control. In fact, one thing you learn today, you drive down the road, the next time you see an excavator sitting on some job, it's got the two masts, you say, hey, that uses machine control, and they've got a BIM model in that thing, absolutely.
Either that or they just like the two big antennas
Yeah.
sticking up top.
Don't they use 3D civil for those things?
Well, Civil 3D sits on top of AutoCAD.
Oh,
Yep, so that's an AutoCAD product.
oh.
And that's how we do all our surfaces, yeah, absolutely.
See-
Once you kind of adopt something too, like, so we've adopted Revit in our office, it's just easier to stick with one program a lot of times. So even simpler projects, you just don't develop it as much. So the levels of development thing I showed earlier, you just stick it to 100. So you still have a model there, it just might not be as smart or have as much information in it. But really, once you've been using the software, sometimes it's just more efficient to stick with it, even on small scale projects.
Yeah, I was gonna go back to that slide I showed. So, we use all kinds of stuff, but it's kind of for that same reason. Each piece of software has its own sort of benefit. So technical structures, we do all of our concrete in. Glue is a collaboration tool like Navisworks, that's where we're doing STEM in as far to put all the models together. Civil 3D, we do our surfaces. Pipe Designer, we do our process piping in. It's a viewer. AutoCAD MEP, we don't use that a lot. It's if we've got a trade that's using it, we're able to open their models. SketchUp we use for kind of complicated embeds in concrete. We can actually take SketchUp and load it into technical structures. Google Earth we use for a lot of business development stuff. Navisworks, of course. Revit we use to manipulate architects' models or use them in coordination. So the hardest part of our job is even not the software. It's how do you get it all to talk to each other and then give it to somebody else that wants to use it. That's 90% of the job.
What is like the master or like the mother program that you can load all of these models into? Would it be Revit, or is it like, what are you using?
No such thing.
If
No
there
such
was,
thing.
If there was, we'd use it.
Yeah, well, I'm not
No,
saying like
it's-
they're gonna do all in one, but I'm just saying like how did you compile all
Yeah.
that data?
Probably the
Navis.
Navis.
We actually did it too. We started it using Navisworks, but we're also using AutoCAD Glue, which is the cloud-based, I almost said worldwide web-based, which is cloud-based. So our contractors can also upload their models to the Glue site. So what the cloud-based program allows us to have a continuous updated model in collaboration. So mechanical contractor can push a model up into the cloud, the electrical contractor can see it within 5 minutes.
And those two actually talk to each other. Navisworks, though, is probably the most used
The best one.
collaboration tool. It can read most file types. The other one that I like, although this BIM site, is a really slick little free tool. You guys can download it if you're interested in seeing it. But it doesn't read all the AutoCAD file types. Autodesk, who owns Revit and AutoCAD, they don't like to play with everybody else, especially Trimble. And so they try to, they want to hold on to their market share. So that's a huge problem, actually.
Mhm.
So Navisworks probably is the best just because they read everybody else's. The other thing that they're trying to have happen, although it's not happening very well, is the IFC file format. I don't know if you read it, if you go under export, you can see IFC. And actually, that's what most of our models end up in at some point. And the idea with that was that any software should be able to export to IFC and then give it to somebody else and bring it in, and it should work perfectly. And that's never gonna, I mean, I shouldn't say never gonna happen, but that's not happening now. I mean, IFC has its place, but it's a challenge. I mean, that's easily the most complicated thing we deal with, is how do we get everything in. I mean, we've even taken, I think it was a STEM, in one of the lecture halls is a curved foundation, and when we brought it in to, I forget it was BIM site or Nanosix, one of them, it flipped the curve of that concrete the opposite way, so we had this huge like bubble sticking out into space. And it's just silly stuff like that that you constantly fight with. Someday, I mean, hopefully before I retire, it all works. Like a push of a button. Then I won't have a job, it'll be robots.
I have a question related to our students. So they're studying civil, environmental, mechanical, or electrical engineering. They've got a pretty heavy course load already. What kind of suggestions would you have for them as far as how much to bring in and of what kind of this graphic kind of engineering? You know, Victor teaches BIM now. Like, where are things going?
Well, as far as hiring for us, I mean, we would love it if somebody could come in and would have all these tools, but they're not.
Yeah.
And I guess I kind of look at it, as long as the person's interested, and really you have to have a desire to learn. Like I was even joking today, we use Bluebeam, which is a PDF program. Like I learned 2 new things today. It was like the greatest day. And if you don't sort of have that attitude, like you've got to, like with Revit, you've got to be able to not want to just hit buttons and go home at the end of the day. It's got to be, you got to try to know what everything does. And if you have that interest, then we can teach you anything. That's easy. Okay. So it's more of an attitude and a personality than it is what you need to learn. I mean, I think it's great that UVM is teaching Revit, because just that learning how to model, what a model is, how it works, that helps tremendously as a background. But then after that, you can learn anything.
If there were any other softwares in addition to Revit, maybe up on that screen, that would be beneficial for UVM to pick up?
Well,
What
being
do you recommend?
being an AutoCAD user, I mean, knowing AutoCAD really well is huge, because everything ends up in AutoCAD. It's
We got AutoCAD, but
Yeah.
what else?
SketchUp is another good one.
All right.
I mean, SketchUp is, we use it as a tool for a lot of little things. It's really, I didn't start using it until about 2 years ago, and I find it incredibly useful. It's so much easier to throw together a quick little model of some part in SketchUp than try to do it in AutoCAD and then move that into something else.
Would it be safe to say that, excuse me, if you know AutoCAD, at least in my point of view, if you know AutoCAD or a CAD type program like AutoCAD, then any aftermarket program, you'd probably be able to pick that up relatively quickly. You know, there's different variations in the user interface, but overall, you know, drawing a line is drawing a line, or a piece of ductwork, or, you know, stretching or creating elements are generally the same.
Yeah, I'd agree, although I've seen people that are fantastic 2D drafters and just don't get 3D.
Yeah.
I guess. So it's maybe goes back to that personality attitude kind of thing. If you're interested in pushing it to the limit, then it's probably the right mentality.
Yep, definitely.
But
I don't know if there's any non-AutoCAD program that would be beneficial for you being able to pick up.
Yeah, no, I don't know. I mean, we love Technical Structures is great. They actually have an education piece of it as well. I think you can get the software really cheap through a university.
Well, we have the whole AutoCAD suite, you know, part of our contract, so. With the Revit component, we're doing all 3, you know, in this project. Doing a little structural part, and first we're doing an architectural part, then we're doing a structural part, then we're doing mechanical electrical component part, but it doesn't really have much plumbing.
Yeah.
But it's doing, you know, and it's just, you know, drag this diffuser here and place the lights here and then tie them, so.
No, I think
But I think my personal, I know about 4 or 5 CAD programs, you know, I've taught over the years, and that, I think Revit is incredibly powerful, but it's quirky in a lot of ways for learning, you know?
They all are.
Yeah.
Yeah, I don't have their different.
Yeah,
Yeah. And so this method is, we would probably grow on the structures part and, because the civils learn SAP for their structural analysis, and Revit structures exports to SAP and back and forth, so we'll probably kind of use that as basis, you know?
yeah, no, I think, we're also small,
Yeah.
we're a small, like, type of user. There's not a lot of contractors probably doing what we're doing. You know, Revit is great because so many, every architect almost uses Revit these
Yeah.
days. I mean, we see it on every single job, so
We're
having
doing
that
a half
knowledge
a
is great.
semester of AutoCAD now, and then a half a semester of SolidWorks in the freshman year. So they've done extrusions and rotations, and SolidWorks is really good for teaching
Yeah.
basic 3D concepts.
Yep.
So some of these guys are the first batch to, these two guys are the first batch to ever go through 3 CAD programs in 8 months' time.
That's great. Yeah, like I said, even the process
So-
is if, you know, transfer those files back and forth, that's even as important as
Yeah.
learning the software itself, believe it or not.
Yeah.
My gut feeling though, down the road, I think we've been having these talks internally, but I think we're gonna end up fully in Revit at some point.
Maybe,
We're not there yet, because it's kind of grown as a design tool,
yeah.
and it doesn't have, especially process piping,
Yeah.
or mechanical, it doesn't have that construction level detail, or that LOD 5, I guess it is. It doesn't quite get to that level of detail,
Yeah.
which is a problem for us, because we want to know every, you know, gasket, and length of pipe, and everything. And it's also it's tough, it's a bigger program, it's tougher to train,
Also,
it's more
they're
infrastructure.
buying all these companies, like they bought Revit and Civil 3D, and they're, when we first switched to AutoCAD in probably 1989 or something like that from CAD keying, I couldn't believe that 60% of the market used it because it was just such a dog. I couldn't believe it. You know, it was just awful program, I thought. And then they gradually improved it because Pro Engineer and other companies started coming in on microcomputers. Because basically AutoCAD owned the microcomputer market, you know, and the silver market, basically, and some of the architects. And then they started improving it, and then they've been buying all these companies, which I was a little worried about, but they've been incorporating them. They've been doing a really good job the last 10 years, I think,
Yeah, they have.
of blending stuff and becoming the big kahuna.
Well, Trimble's good.
I'd like to add one thing
Yeah.
before
Yeah.
we get too late. And
Yeah.
as just, John, maybe you want to talk a little bit about tours or anything like that, because we've got like a month before finals, and we have like 2 or 3 weekends, or 2 or 3 Fridays. Fridays work really well for us, because at 3:30, the guys are generally gone.
Okay.
And if anybody wants to tour the site, it's a nice time to do it, because we're fairly far along on the first floor. We've got a lot of work going on the second, and as you get to the air handling, you can see 2 air handling units in this STEM building. If you can imagine 4 school buses stacked on top of each other, that's the size of one air handling unit. 158,000 pounds for one.
Did you have the films of the cranes putting them up there?
Yeah, I mean, it's
They-
quite,
they
it's
have-
actually a good time to go see
Yeah.
the job, but we'll have like 3 Fridays before you guys get into finals, so we should try to put something together. I know Vermont Tech is coming up on the 26th in the afternoon, which isn't a Friday, which doesn't work great, but I
Okay.
wanted to say
All
that.
right.
Plus, as far as just talking about this whole career avenue, I think of it as a career avenue. You can think about, we didn't even have a virtual department 2 years ago,
4 years ago.
4 years ago.
I started, that's what I was
Yeah.
hired for, 4.5 years ago to
Right.
start the department.
That was, he was the department. And now we have, we actually have, how many people now?
6?
It's growing
6
fast. I
people.
Yeah,
mean,
6, yeah.
this is growing fast, and as we expand, we'll be expanding the department. It's a good career avenue, I guess, what I want to say.
Okay,
Skill
great.
sets.
Yeah, it's a good skill set.
Well, I just want to impress everybody that, not impress upon, just impress that back in 1982, I was using AutoCAD version 2.
Yeah.
And on a computer that was probably, I don't know, actually probably had less horsepower computing than my cell phone has. So.
Yeah, I used to hang them on, and mice were the wonderful invention.
Yep.
Back
Anybody
in
else?
1976, we were just starting to use the fax machine.
All right, this isn't a history class.
Yeah, right. It's all part of history and engineering. Well, you know, we used to carry those. Evan says, you know, I'm trying to carry these into the building. Well, guess what? One contractor would have carried the full-size set of those plus 2 binders of specifications.
Well, you always hired a really beefy apprentice.
What's that?
Your apprentices were always big and strong.
Oh, yeah.
Yeah.
Austin, did you have a question?
I did. So with the future being so reliant on these new programs, do you see any potential dangers associated with that?
Yeah, one, like, a good example is that Pipe Designer 3D is owned by Trimble, and they're starting to hoard, just like I was gonna say earlier, like Autodesk, they're hoarding up all these other small companies. In fact, that used to be called QuickPen. And it's difficult to know what their plan is. So in fact, Tekla is owned by Trimble as well, and when we got into Tekla, I think the purchase had just happened, and they were still their own thing. And I knew my salesperson on a first name basis, all the support people I knew.
Yeah.
And now that Trimble is kind of fully taken over, I don't even know who our salesperson is anymore, and it's really scary. So I don't love the big company thing, but on the other hand, they have money to put into products. So when they do decide to make it a good product, like Revit,
Yeah.
it happens. So I don't know, it's kind of I don't know, lesser to you, I don't know.
Yeah, it
It's
used to
scary
be
though.
everybody had a microstation package in their firm, so they could import and export AutoCAD files. Because it was the only one that would read AutoCAD 13 in and write out an AutoCAD 14, because AutoCAD 14 didn't do it. But MicroStation, they were the ones that all the state transportation agencies own, like 49 out of 50 of them. And so, and all the little firms would use Autodesk, right? So but the state wanted them in MicroStation.
It's kind of like Microsoft.
It's a wild thing that they do. AutoCAD has a history of being disruptive, because they had the DXF file was the digital export file, and theirs would never work, right? You know, they owned so much of the market that it wouldn't quite import and export. You know, it really isn't that hard of a thing to do. It's just a list of points, you know.
Yeah,
So,
that's true.
so the bleeding edge they resist on, but then the old stuff they just let it work, you know.
I think it's market share, they just don't
Yeah.
want other people
Yeah, it's market
messing with
share,
their
yeah.
business.
Yeah.
Well, thank you very much.
You're welcome.
Great, thanks for all your preparing.